about solving compound inequalities. Okay, absolute value inequalities, we're going to cover that on Monday. Okay, but so first of all, a compound inequality is basically two inequalities joined by the word and or the word or. So two inequalities joined by the word and or the word or. Okay, so the graph of a compound inequality containing and is the intersection of the solution sets of the two inequalities. And so when it means intersection, what does that word mean? Like, what is a street intersection? Where two streets meet. Okay, where two streets meet. So when we're talking about the intersection of the solution sets of the inequalities, it's where they meet, it's where they're in common. And so up here on the board talks about if I have my first inequality here going to the right, and my second inequality here going to the left, the and is what's in common with the two. And so I start here at -4, that's what's in common. Everything now between the two is in common, and then when I get to 3, I'm going to use an open circle because 3 is not in common with the bottom one. So and is what is in common with both. Okay, so let's go and look at an example of this. Okay, it says solve 8 is less than 3y minus 7 is less than or equal to 23. Now this, believe it or not, is actually an and statement, but what I'm going to do is I'm going to leave this written this way, and I'm going to show you a way to solve this. So what I'm going to do is I want that middle to be y, only y. I don't want it to have the 3, I don't want it to have the -7. So what I'm going to do is I've got to get rid of that -7, okay? And to get rid of that -7, I'm going to add 7, right? Now the thing is with this inequality having 3 distinct parts, you have to add 7 on each of those 3 parts. Okay, see how I did that? So I added 7 with all 3. Now what I'm going to do is I'm going to take 8 plus 7, which is 15. In the middle, my 7s are going to cancel, and I'm left with 3y. And then I've got 23 plus 7, which is 30. Now, once again, I need to solve that for y. So what am I going to do?
Divide by 3.
Divide by 3, and I've got 3 different parts that I need to divide by 3. So I end up getting 5 is less than or equal to y is less than or equal to 10. Now, the beauty of this problem is that I don't have to worry about doing 3 graphs. I can just do 1. And so what I'm going to do is I'm going to look at what I'm given in the problem. And notice here, it says that my solution is between 5 and 10, correct? So in looking at that, what type of circle would be at 5? Open. Why is it open?
Because it's not equal to.
Because it's not equal to. So there's your open circle at 5. What type of circle at 10? Closed. And so in this situation, what I'm going to do is I'm just going to shade in between both of those graphs. And there you go. Now that's the nice ones with and. Okay? The ones that are a little more work is the next one that we're going to look at. Okay, actually I take that back. We're going to go ahead and just look at this one.
Is that a hard? Is this a different?
No, this is about the same. We're just going to look at this one again. So what do you think you're going to do first?
Add 2.
Add 2. So I end up getting -3 is greater than or equal to 3x, which is greater than -12. What am I going to do now? Divide by 3. So I end up getting -1 is greater than or equal to x, which is greater than -4. Now, if that would have been a -3 that you would have divided with, you would have had to flip those inequalities. Okay, that's what we learned yesterday. And so then now, what type of circle? Okay, so I need to go ahead and do my number line, so I'm going to go and start 0, -1, -2, -3, -4. What type of circle do I put at -4? Open. Okay. I do an open circle at -1. Okay. There we go. Maybe. Ah, where's the little hand? We're having trouble with.
Just draw it.
Okay, well then the next one we put a closed circle on, -1.
You have
Okay.
to put a circle in?
Yes. There we go. Open circle on -4. Okay. And so then I'm going to go ahead and shade in between.
When would it be that you had to switch the, or you would have said something?
If it would have been a -3 that you would have divided by. All right, so that's the first types of compound inequalities you're dealing with. Now we're going to talk about another type, and these are using the union. And so the graph of a compound inequality containing the word or is the union of the solution sets of the two inequalities. So when we have a compound inequality and it uses the word or, notice here are my two inequalities that I start with. This is my final answer. If I look at this, in order for it to be shaded in the answer, it just has to be shaded in 1. So here, the left arrow is shaded. It's shaded right here. So that means I'm going to shade the left arrow. Okay, I keep going up until -3, and that's shaded. The middle here is not shaded at all on either one, so it's not going to be shaded in my answer. And then on the right side of the graph, this is what's shaded, so it's going to be shaded in my answer. And that might not make a lot of sense right now until we look at our first example, and then it might make a little more sense. So let's look at this inequality. Okay, this compound inequality states that k plus 6 is less than -4, or 3k is greater than or equal to 14. So basically what ends up happening is I need to solve each of these individual inequalities. And then what I will do is combine the solutions. So to solve that first one, what am I going to do? -6. So I end up getting k to be what? Less than -10. Okay, so okay, so tell me about that graph. What's it going to be? Yep, open circle where? An open circle on -10. Let's see, there we go. And which way am I going to shade? To the left. Okay, because it's less than. Okay. Now I need to solve the next inequality. So how do I solve this inequality? What do? Divide by 3. Now if you notice, this isn't a nice and neat one. This actually gives us, okay, an improper fraction. What is 14/3?
4 and 2/3.
4 and 2/3. So what type of circle am I going to use? Closed, and I'm going to go approximately at 4 and 2/3, so about right here. And then which way am I going to shade?
Right.
To the right. Okay, so I'm going to shade to the right. Now comes our final answer, and what we're going to do is compile these two graphs into one final graph. Now, in order for it to work with OR, I just have to have it shaded in one location. So is the left arrow shaded in at least one? Yep. Okay. Is this still shaded?
Yeah.
Where do I stop? Right there, and I put an open circle. Okay. Is -9 shaded? -8? Where do I start shading again? 4 and 2/3. So right here. And then which way do I shade? To the right. So that final graph is going to be where your answer is. That's your answer.
So three different graphs.
The 3 different graphs help you to see how they all relate, but this is your final answer right here.
So when we show our work, do we need to show 3 graphs?
I probably would because it makes it a lot easier. Okay, they don't have to be super detailed. Okay, you can just draw 3 real quick ones in. But if you don't, that's kind of, I think, when you'll struggle. Let's look at another one of those. So we have 5x is greater than or equal to 15, or negative 3x is greater than or equal to 21. So what am I going to do? Divide by 5. So what is x going to be? X is greater than or equal to 3. Okay? What type of circle will I put it at positive 3? Closed. And which way am I going to shade? To the what? To the right, it's greater than. What do I do on the next one? Divide by negative 3. So x is less than or equal to negative 7. Okay, why is it less than or equal to? You divide it by a negative number. So I'm going to put a closed circle at negative 7. And which way am I going to shade? To the left. Okay.
Will there always be one going one way and one
Oh, so you just watch this. Sometimes
Yeah.
they both go the same way?
Yes.
Oh, that's
And that doesn't change anything. I mean, there's your one half of the solution. Here's your other half. Now, this is the thing. You know, I know some people are saying, well, how would you do that? Okay, imagine that you had a closed circle here at 3, right? Let's imagine we had an open circle here at 0. And it looked like this. Basically, the solution set's going to be the pink line. Okay, yeah, you wouldn't even need this one because everything that's here is already included in the pink line, right? So that's why if they both go the same direction, it doesn't really change things. I mean, you're still looking for where they're shaded. And so this one, it would be shaded down here, and then it would just go to the right. Okay, it's a good question. All right, so I'm going to go ahead and stop. We're not going to do the absolute value inequalities. Okay, we'll continue with this on Tuesday. But if you want to go ahead and get started, here's what you can get started on. Okay, pages 45 through 46, 12 through 20 the evens, 34 through 40 the evens, and 46 through 50 the evens.